The topic is evaluating trigonometric functions for an angle given a point on its terminal side. So first, let's read the definition. The definition says, if you have a point AB right here on the terminal side, then by drawing right here, by drawing the unit circle, this point is always going to be A over R, B over R, always, by definition. Alright, so let's try to do this example. Find the exact value of each of the 6 trigonometric functions if the terminal side of an angle x contained a point 4, 3. So first of all, 4, 3 will be here. This is 4 and this is 3. So we're looking at, well, let's just draw a line. So all we're interested in is the unit circle. This is the unit circle. See, the radius is 1. So if we can find this point, then the rest will be easy. But by definition, this is going to be A over R. See, this point is 4, 3. So we need to find R. So let's find R first. So what would be the radius? We mean the radius from here. This is the radius all the way here. The radius of the big circle. This is R. Let's just not draw the whole circle, but this is what we mean with the big circle. Right? So, I mean, it's pretty easy to use Pythagorean theorem. Just draw a line here. So it's actually R squared is equal A squared, which is 4 squared plus 3 squared. So R squared is equal 16 plus 9, which is 25. So R is equal 5. Remember, R has to be always positive. So in this case, R will always be square root of A squared plus B squared. This is how you find R. So now we know R is 5. So this point right here is going to be A over R, which is 4 over R, we said is what, 5. And then the y value would be B, which is 3 over R, which is 5. Once we find that, the rest is pretty easy. Remember, the cosine of x is always going to be the A, and sine of x will be the B. So now we know cosine of x is A, which is 4 over 5. The sine of x is B, which is 3 over 5. And the rest is easy. Why? Because tangent is always going to be, let me do it here. Tangent is always sine over cosine. But what is sine over cosine? It's 3 over 5 over 4 over 5. Simplify the 5, you get 3 over 5. I mean, 3 over 4, sorry. 3 over 4. So this is 3 over 4. Now secant, cosecant, cotangent are pretty easy. All you do is invert. Secant you invert 4 over 5, you get 5 over 4. Cosecant you invert the sine, because it's 1 over sine, which is 5 over 3. The cotangent you invert the tangent, which is 4 over 3. And that's it for this example.